Hello and welcome to the show you know and trust to bring you all the important information about movies and their reality, science and the cinema. My name is Joe King, and in today's episode we have Dr. Manal Patel joining us to talk about what it's believed to be one of this decade's most scientific and most intriguing films, Interstellar. So Dr. Manal, you're NASA's leading astrophysicist. What's your opinion on this film? Thank you so much for that, Joe. I think it was a great film too, actually, and I think it was done quite well, not only as for the scientific perspective, but also as a film and a storyline. I thoroughly enjoyed that. The large part of the reason why why the science was so good behind it was as they had hired Kip Thorne, a professor an astrophysicist from Caltech, to not only be the scientific advisor, but also oversee the film and become a producer to make sure that they got everything right till the end of the production phase. Funny you should mention that. It was more or less accurate. As an average moviegoer, I found the film quite spectacular, and it made me, learn a lot of things, question many things that I learned in school, remember a lot of things from school, what I've learned before previously. One of the things that not only intrigued me, but also the audience, was the time slowing down on different planets when Cooper lands on different planets compared to Earth. Is that a possibility? Is it accurate? If so, how can it be? Because to all of us, it sounds very wild and it's nothing that we've learned before. Yeah, many people had the same notion of not knowing what was going on, how that worked. However, it is accurate. Yes, time does slow down when you're further away from Earth's gravity or closer to black holes, as it's known as. It's called time dilation, and it was first observed and proven by Albert Einstein. We can use relative equations and his theory of relativity to prove this. In the film, we see Cooper and his crew travel to Gargantua, which is a black hole that they've named in the film, and the planets that orbit the black hole, and possibly living on those planets, and see if they were habitable for humans. The first planet that Cooper and his crew go to, the one which had massive tidal waves, which, by the way, are possible. That's what would occur. As for them being tidal waves, it's unlikely. It would more so be a massive, let's say a hill kind of water when you're further away into the ocean and waves don't crash, you just bob over them. That's how it would be. However, that's not the point. When they land on the planet, we see that 1 hour on that planet equals to 7 hours on Earth, and which is quite possibly accurate depending on where that planet was or how close it was to the black hole, which we don't know. This is actually a very common phenomenon, and we don't see it personally with our eyes because it's so minuscule on Earth. But however, if you had a clock on a tower compared to a clock at the bottom of the tower, the clock on top of the tower would tick just the tiniest bit slower than the one at the bottom. The best place that we could possibly see this is through our GPS. We have satellites that orbit the Earth much above the atmosphere, or in the atmosphere, that is further away from Earth's gravity and closer to the sun's, which means time on those, or the clocks on those, are slower than the ones at the bottom of the Earth or on our ground. Which means that when we receive the data, for example, when you're navigating somewhere, it would have the wrong time. In order to correct this, what scientists do is they calculate how much slower these clocks are running, and they pre-adjust them to match the time that's on Earth, so we get the correct data every single time. However, there are many aspects of this film that I don't believe are so accurate. Let's say there exists a planet that they enter like this. The possibility of a planet being so close to the black hole is highly unlikely, because we don't know how the planet came there in the first place. It could not have just existed there, as it would be being sucked into the black hole as it's so close. It can't have naturally formed there. It could only be being sucked in, which means that we can't really live there. It's not a habitable planet, as it's so close that it would have no lights. The only thing that would have on there would be X-rays, and those X-rays wouldn't be good for humans or any sort of habitat on the planet. As well as that, it would be so close to the black hole, and as the black hole will be sucking the planet, you can imagine a planet as a ball, and if this side's being sucked in, as it's spinning, the other side's not, which means that it elongates the planet, and as it spins over, it would have massive bulbs on there. Imagine the water, and when the water gets on the ocean, it gets a bit choppy, and you have those massive curves or bell curves on there. That's similar to what would happen due to the tidal forces. It would literally rip the planet apart into pieces. Right, that's interesting. But let's say there exists such a planet. Could we possibly go there and live there? Is there such a way we can do that and we can land on there? So if, let's say, the planet, survives, and the planet doesn't rip apart due to tidal forces, and it's somehow orbiting the black hole that closely, could we live there? It's very far-fetched. The reason for that is, to get onto the planet, we have to land on the planet. In order for us to do that, we need to match the speed the planet is orbiting at, which, if it's that close to the black hole, would be almost the speed of light, or very close to the speed of light. And when we can't reach the speed of light ourselves yet with the technology that we have, if we somehow manage to get it, it would still be extremely difficult, as we have to match the speed, then somehow find a way to get down to the planet, all without being sucked in by the black hole. So all in all, it's a very unlikely scenario that would ever. Maybe Elon could whisk us something up, who knows. But I would love to get your opinion on black holes and how Nolan and Kip have shown them in the film, because a lot of this film is about the black holes and how we could use it to our benefit, possibly in the future, if there was such a case. And a lot of the things that they talked about black holes, I don't remember learning in physics before. Maybe he could. But no, this is a very interesting question that you bring up, because there are many aspects of what Kip and Nolan show about black holes that are so spot on, especially for its time when we didn't have as much information about black holes as we do today. And I'll give it to them that they've got the right concept there. And they're very close to what black holes would actually be like. However, there's a couple of things that they still miss or use creative freedom for, and that's okay. It's a movie at the end of the day. They need to move the story forward. Some of the things that they did really well, I was really impressed by how Kip used Nolan and all of his designers to design what a black hole would look like with an insertion ring around it. So the images that we see of the black hole in Interstellar are very similar, or extremely similar, almost the same images that we finally gathered in 2019 of a black hole. This was the first images that we received of any black hole, and if you put them side by side, you can see that they're extremely similar. There's barely any differences. You can see the insertion ring being warped around it, because obviously we have 2D pictures, we can't see it more clearly, we can't get any closer. And Kip's model and mathematical model that he used to draw up or design and animate the black hole is extremely similar to what we actually have seen of black holes and what they look like now today. But to have that many years ago, before we even knew what they looked like, is astounding. So he was spot on there. However, the idea that Cooper can enter a black hole and survive, not so accurate. We have not tested what would happen if someone or something was to enter the black hole. However, we know what a black hole is. We have mathematical models of what a black hole is and can do. And we've seen what black holes can do from afar. We may not have proof, as we've not tested exactly what would happen, but it's widely accepted that it wouldn't be good and you would not survive. After being sucked into a black hole, while being sucked into a black hole, after a certain point, what starts happening is your legs would be falling faster than your head, which means you'll get elongated and keep stretching out, also known as being spaghettified, and eventually you would snap into two. And then both of those parts will again be elongated and stretched out until they snap. And this would keep on occurring until you reach single atoms or singularities, and it would keep going. So, therefore, in my opinion, this film has done really well, and overall, it's an amazing film. I would recommend everyone to go watch it. And to take most of the science as pretty accurate, however, they've used creative freedom here and there to drive the story forward, which is not wrong. They've made sure they've gone and gotten all their basics right before they've moved on and used that creative liberty to alter some things in order for you to make it more interesting and more of a storyline so that you can enjoy as an average moviegoer. Thank you so much for that insight, Dr. Patel. It was lovely having you on the show. Thank you so much for having me. And thank you to all of our audience for tuning in. Until next time, this is your host, Joe King, signing off.